Hello, fam. This is Zekaya from Mathatainment, reminding you that enthusiasm implies excellence. We are still dealing with our so-called non-routine exercises, and we are doing this under Algebra, grade 12. The problem that we are faced with is as follows. We are required to determine the sum of the digits of 25 to exponent 30 multiplied by 2 to exponent 60. How do we go about doing this? You can see that we have a product there. Since we have a multiplication sign, that means we have a product. And the first power there is 25 to exponent 30, and the second power is 2 to exponent 60. So we may want to write both these powers to have in such a way that they have the same exponent. So let us start. So here, instead of 25 to exponent 30, I'm going to write this as 5 to exponent 2 times 30, because 25 is the same as 5 squared, multiplied by 2 to exponent 60. Well, by doing this, I know that 5 to exponent 2 times 30 is the same as 5 to exponent 60 multiplied by 2 to exponent 60. Well, by laws of exponents, we know that if we have a to exponent m times b to exponent the very same quantity, which is m, we can write this as a product, which is ab, and then both of them, they take this exponent, which is m. I can do that. So following this, you can see that there you are allowed to write 5 times 2 to exponent 60. And 5 times 2 is 10, and then now it has an exponent of 60. Well, now we need to think a little bit. I'm going to show you this from my famous calculator, how it goes. Powers of 10. Here we are dealing with powers of 10. The first power of 10 that you can think of is the simplest one, 10 to exponent 0. And by the way, that is equal to 1. 10 to exponent 0 is 1, without a 0 on the right-hand side of 1. And then, when you have 10 to exponent 1, you have 1 0 in the right-hand side of 1. The moment you have 10 to exponent 2, there are 2 zeros in the right-hand side of 1. And when we have 10 to exponent 5, for example, you can check there that we have 5 zeros in the right-hand side of 1. So now, we don't even want to create much padding for our calculator. From here, we can deduce that when we have 10 to exponent 60, we have 1, and then in the right-hand side of 1, we are going to have 1, 2, 3. The bottom line here is that we have 60 zeros in the right-hand side of 1. So we have got 60 zeros in the right-hand side of 1. But the question says we want to find the sum of the digits here. We want to find the sum of the digits. So therefore, the sum of the digits of this quantity is actually 1 plus 0 plus 0 plus up to the 60th 0. So it means it's 1 plus 60 zeros. That remains 1. This is the answer. The sum of digits here is 1. Who may have thought that the answer here is 1? The problem looks a bit scary, but the answer here is 1. We just used our laws of exponents and then a little bit of thinking in terms of when we think about the powers of 10. So the sum of digits for that problem is 1. Let's look at another one. Another one is as follows. If you have a square root, and underneath the square root, you have 7 to exponent 2014 minus 7 to exponent 2012, all over 12 is equal to a times 7 to exponent b, where a is not a multiple of 7. Determine a and b. Let's see if we can determine A and B. We're going to try and represent this quantity on the left-hand side, which is in the form of a square root there, and we'll write it in such a way that it looks like A multiplied by 7 to exponent B. Okay, let's try doing that. In fact, let us do that. So we have this square root over there. Then in that square root, what I will do, I will take out 7 to exponent 2012 as a common factor. 7 to exponent 2012 as a common factor. So I have 7 to exponent 2012 as my common factor. You may remember from our previous lessons, we said whenever you take out a common factor in an expression, what remains inside the bracket, to find that, you divide each term of an expression with the common factor that you took out. So here we are going to have 7 to exponent 2014 divided by 7 to exponent 2012 minus 7 to exponent 2012 divided by 7 to exponent 2012. So let me elongate my square root there and going down there. And I'm closing my brackets now. This is all over. In our denominator underneath the square root, we just have 12. So here, guys, what we have now, I still have my square root like this, and then I have 7 to exponent 2012. Then inside the bracket here, inside the bracket, as you can see that you have got these two powers and they have the same base. They have the same base. So you will take one base, which is 7, and then you subtract their exponents. So you will have 2014 minus 2012. That will give you 2 in the exponent. And again, here you have 7 to exponent 2012 divided by 7 to exponent 2012. We are dividing basically the same quantity, so there you just have a minus 1 all over 12. See, our problem is getting simpler and simpler. And still we have this square root, and then you have 7 to exponent 2012. 7 to exponent 2 is actually 49. 49 minus 1 is exactly equal to 48. And remember, we are dividing by 2, and the 2 is still under the square root. So we are dividing by 12, and the 12 is still under the square root. So here we have a square root of, remember, we have 48 divided by 12. That's something that you can find. 48 divided by 12, I will write 4 here because that is 48 divided by 12. Multiplied by 7 to exponent 2012. And 4 has a precise square root, and the square root of 4 is 2. And now we are left with a square root of 7 to exponent 2012. Well, this is something that I need to remind you of again. When you have an nth root, and within that nth root, you have a number that is exponentiated to some exponent m, this is the same as a to exponent m over a. And here, since we have a square root, the number that resembles n there is actually 2. That's why we can write that quantity as follows. We are going to write this as 2 multiplied by 7 to exponent 2012 all over 2. Well, I'm going to shift this slightly and write it this side. This is the same as 2 times 7 to exponent 1006. And remember here, we want to find our values of a and b. And by looking at this, you can see that your a is actually 2 and your b is 1006. These are your values of a and b. We just changed that quantity and made it look in this form of a times 7 to exponent b. So this is how we end our lesson for today. Thank you guys. I can't wait to meet you again on our next video.